I'm Anil Kumar, and in this video we'll quickly review the domain and range of parent functions. As you know, domain is set of all independent variable values which you can have for the function, and range are the set of all dependent variables which are the outputs, right? We need to find domain and range of parent functions. The parent functions could be like a linear function. So let me just make a diagram here, and then we'll talk about them. So one of the functions is the linear function. Let's say y equals to x. Let's say this is my first function, and we'll write here f of x. Let's say L of x. L of x is my linear function, which is equal to x. So it is kind of y equals to x, right? Now for this function, we know domain is all real numbers. So what we can do here is kind of make a table. Okay, so we'll write domain here, domain, and then we'll write range of the function. So let's make a table. I didn't think about it earlier, but now I think it's a good idea. So we'll make a table and then fill it up. Okay, for different functions. That's good. So since we want lesser space to be utilized, we'll write them in the interval notation. So here the domain and range has no restriction. Domain is from minus infinity to plus infinity. Range is also from minus to plus infinity. Perfect. That's good. Let me sketch some more functions here which are kind of similar. So you could call this a polynomial of degree 1. And if I draw another function here which is kind of a parabola, y equals to x squared. So I'm writing this function as y equals to x squared. So let's write down function name here. So I'm just defining the functions. So we'll write this as a parabola. P of x is equals to x squared. Now in this particular case, you can see domain has no restriction. It is from minus infinity to plus infinity. However, the range has a restriction, and it is from 0 to infinity. Some of you must have noticed I made a mistake. I have to include 0. Correct. So you should include 0. This point, origin, is right there on the curve, and it should be included, right? So we get this. Now let me add one more here, and that is a cubic function, which is kind of like this. Okay, so which will be kind of like this. So we'll call this function as c of x. The cubic function is equals to x cubed. And here, there are no restrictions on the domain, minus infinity to plus infinity, neither on range, minus infinity to plus infinity. All polynomials which are odd degree will not have any restrictions on domain and range. However, odd degree. However, even degree polymers, let me write, even degree, maybe x to the power of 4 or x to the power of 6 will have same behavior, right? This is odd degree. Odd degree, maybe x to the power of 7, x to the power of 11, they will have this kind of behavior. I hope that helps you to understand the concept. Now let's move on to different kind of functions. We have enough space here, so we'll take the function which is a restricted kind of function. So we'll take function like square root x. So square root x is kind of like this, right? Okay, so let me write down the name. S is good name, s of x, right? So which is square root of x, and domain range, 0 is included, so 0 is included, and could go to positive infinity, which you can never include, and then range is exactly the same. It is in quadrant 1, right? So both are through the origin. Origin is included in this particular case. Now there's another very restricted function which is half circle. So if I write this, kind of like this, half circle. If I make a full circle, it is not a function. It fails the vertical line test, right? So that is not a function, right? So half a circle is a nice function. We could do that. Now what should be the equation of this? Okay, so hemisphere is h, right? So h of x is equals to, so do some math here. We'll do square root of 1 minus x squared. x square plus y square is 1. That's the circle with unit, right? So this is minus 1 and plus 1. When I rearrange, h of x is 1 minus x square root. So that is your semicircle, another function. Here, both domain and range are very much restricted. Domain is between minus 1 and plus 1, and the range is between 0 and 1, both included, correct? So that's a very good function to know. And then we'll move on and we'll add one more function here. So let me use the same space for the third function. Okay, should I? Okay, let me add. Okay, so it's interesting. Since the third function is the absolute function, they all will go to this point 1. Okay, so that is the interesting part. So this is my absolute function, and we say a, right? Okay, absolute function a of x is equals to absolute x, and as you can see here, the domain has no restriction, minus infinity to plus infinity. However, the range is restricted like a parabola. It's also an even function from 0 to infinity, right? So let me take up sinusoidal function now. So we'll take trigonometric functions. We normally use sine. Sine is transformed cosine function, right? So just taking sine can represent sine and cosine both. So let me sketch this function here. It is kind of like this, right? So it is kind of like this. Okay, so that is how it is, and it goes both ways. Okay, so that is your sine function. We can write s of x as equals to sine x. Okay, now what is the domain and range for this function? Domain has no restriction, right? So it is from minus infinity to plus infinity. As far as range is concerned, it is from minus 1 to plus 1, both included. So minus 1 to plus 1. So that is your sine function. Now in the same diagram, I will make tan function also, and sine over cos is the tan function, which will be kind of like this, pi by 2. Okay, and the sketch for that function, as you know, is kind of looking for a pen. Okay, let me use this one. Okay, that's fine. Okay, this is okay. So the tan function is kind of like this. Do you see that? So, and kind of repeats. It kind of repeats here. So I'm just drawing a few more. So as you can see here, it has restrictions. These points are not there in the domain. The vertical asymptotes, which are at pi by 2, right? They are not in their domain, right? So pi by 2, odd multiples of pi, correct? Pi by 2 are not in their domain. So for tan x, let's say tan x, x belongs to real numbers, but what is not included is that x is not equal to pi by 2 times 2n plus 1, where n is any integer, right? So pi by 2n plus 1. However, in the range there is no restrictions. It goes from minus infinity to plus infinity. But in the domain, these vertical asymptotes are at x equals 2. Let me rewrite this. Okay, odd multiples of pi by 2. So odd multiples is 2n plus 1, where n belongs to integers, correct? So that's what I'm writing here. So that could be a trigonometric function, tan, and then we know sine and cosine are same, right? So you could do cos also here, both are same. So this kind of gives you a good review on what functions we have learned. I forgot about the reciprocal function, so let me add that up also. Now where? Okay, reciprocal function is 1 over x. So 1 over x is okay. So so at 1, okay, let me write down somewhere here. So r of x, let me write down somewhere. So we forgot one fact. Reciprocal function, r of x is 1 over x. Clearly, x cannot be equal to 0, right? So here, domain is x is not equal to 0. As far as y is concerned, y also is not equal to 0. So you could write all real numbers except that. And to sketch it, what we can do is, we know that Okay, so we can just sketch it here. So it goes through this point 1 and this will be kind of like this. Is that okay? So that function will be reciprocal function. Okay, so this is your reciprocal function 1 over x. Okay, so not to think much. Okay, that is your function. Is it okay? R of x. R of x. So reciprocal function is unique that it has horizontal asymptotes, just as exponential function, which I also forgot. Okay, so let me add that one also. Exponential function will be, since this is 1 for us, it will be kind of like this. So okay, so I'll sketch here itself. We messed this up a lot, so let me just mess this up more. Okay, this is our exponential function, which will go through 1. So what I'm saying here is 2 to the power of x. Now here the domain is, as you can see, x belongs to real numbers. However, the range is y is greater than 0. Okay, so that is the exponential function. Well, I hope that covers most of the functions which you have read about, and you can take this as kind of a review of all that. I'm Anil Kumar, and I hope that helps. If you like it, you can put some likes. Also, share and subscribe my videos, and feel free to post questions. Thank you, and all the best.